Let us study about free electron theory of metals. To understand this, let us recall that in case of a conductor, the current is because of free electrons. Free electrons are those electrons which are least bound to the nucleus. Since these electrons are least bound to the nucleus, the electrons will move in the material. So, we can say that electrons in a conductor will move in random directions randomly. That is, if we consider a section of a conductor and if we look at just one electron's motion, now this electron will move randomly. It will move like this, it will collide and move like this, it will collide and move like this. It will have random motion. Now if you look at all the electrons, then all the electrons will move randomly, which means each electron will have its own velocity, but the velocities of electrons at any point will be such that the net velocity will be equal to 0. That is, if the arrow is given here, represent the electron's velocity at a given point of time, then there are so many electrons that the net velocity of all of this would be equal to 0. So we can say the average velocity of these free electrons is 0. But the average speed is not 0 because speed is just adding their magnitudes, not with direction. So we can say that at any given point of time, the net transport of charge in any direction is 0. That is because an electron may move like this, one may move like this, such that the effect of these two would cancel each other. So the electrons are moving, but the electrons are moving randomly such that the average velocity is 0, which means net transfer of charge in any direction is 0. We know that current is given by charge by time. Since net charge is 0, then current also becomes 0. So just free electrons is not sufficient to get current, rather we may need to pull them in a given direction. So this represents a typical motion of electron. As seen here, the electron has a random path, and if we average for all the electrons, then that turns out to be 0. Now to make the electrons move in a given direction, we need to apply a potential difference. Suppose if we apply a potential difference between these two ends called as end A and end B with the help of a power supply like a battery, then the electrons have been pulled in one direction. Now even here also electrons will collide. For example, if we look at the motion of one electron alone, then a given electron may collide with a, say, atom or molecule, and then without the applied field, the electron will move randomly. That is, electron may move like this and collide and move like this and move like this. It has random motion. But in presence of an external applied electric field, even here the electrons will move. But here what happens is, after collision, electrons have been pulled in a given direction, which means the electron will collide. For example, think the electric field is in this direction. The electron will move against the electric field. So electron may collide with a, say, atom or molecule. After collision, it's been pulled forward in this direction. So electron tends, it tries to move in this direction only. So it may collide and move like this, again collide and still move like this, and collide and move like this. So the electron is trying to move in only one direction, which means if you look at all the electrons will collide with the neighboring atoms or molecules, and after collision they will all try to move only in one given direction. So in this case, the electrons will have an average velocity or average speed. That velocity is called as drift velocity. The name drift is again a common English word. Drift means moving along a particular direction. Now here, the electrons are drifting. Electrons are moving because of the applied electric field. So the electrons will have an average velocity, and that average velocity is called as drift velocity. Mathematically, it is given by V drift is equal to E, capital E, tau by m, where E is electron charge, capital E is electric field, tau is called as relaxation time. We'll define what this means. Relaxation time, and m is mass of a electron. Here it is negative, just to imply that if electric field is applied in this direction, the electrons will move against the electric field. So this minus sign indicates that. So this is called as drift velocity.